Questions. Number 1. A plane leaves airport A 40 degrees south, 36 degrees west at 1400 hours on Monday and flies due north to airport B 50 degrees north, 36 degrees west. Part A. Calculate the distance the plane covers in kilometers. And then you're told to take pi to be equal to 22/7 and the radius of the earth to be equal to 6370 kilometers. 3 marks. Part B of the question. After a 45-minute stoppage at B, the plane flies due east to airport C, a distance of 2,550 nautical miles from B. Find, Roman 1, the position of C. 4 marks. Roman 2, the local time the plane lands at C if the average speed for the whole journey is 1,200 kilometers per hour. 3 marks. And then you're also told to take 1 nautical mile to be equal to 1.854 kilometers. Something to note. When answering questions in this topic, you need to have a sketch. A 2-dimensional figure will do. So you draw a circle and then you represent the diameter in the horizontal direction to represent the equator, and then the diameter in the vertical direction to represent the Greenwich meridian. We need to have a clear picture of where the points lie on the Earth's surface, be it in a great or a small circle. Now let's consider the solution for number 1. So we are going to start by locating the points. So we'll start by airport A. We've been told it is on a latitude 40 degrees south and on a longitude 36 degrees west. So this is where we find point A. And then point B, we've been told it is on a latitude 50 degrees north and on a longitude 36 degrees west. So this is where we find point B. So the plane will be flying from airport A to airport B. And remember, in the first question, you've been told to calculate the distance the plane covers in kilometers. So moving from point A to point B, it's along a great circle. So we're going to find the distance in kilometers along a great circle. So the solution for part A, we are going to have distance in kilometers along a great circle. Along a great circle. We know the formula will be equal to theta divided by 360 degrees times 2 pi r. And the value of theta will be equal to, we've got 50 degrees on the northern hemisphere and 40 degrees on the southern hemisphere. Adding them together, we are going to get 90. So the value of theta will be equal to 90. We are going to have 90 divided by 360 degrees to multiply 2 times 22/7 and then times 6370 kilometers. So the solution we are going to get here is 10,010 kilometers. And that is the solution for the first part, the distance from airport A to airport B. And then in part B of the question, we are being told that after a 45-minute stoppage at B, the plane flies due east to airport C, a distance of 2,550 nautical miles from B. And then you're told to find the position of C. So therefore, we will know that the position of C will be right on the eastern side of airport B. So this will be movement along a small circle or a circle of latitude. So since we want to find the position of C, we need to know the value of theta. So we're going to know the value of theta from the formula, distance in nautical miles along a small circle. And this will be equal to theta times 60 cos beta. And the distance between point airport B and airport C, we've been given as 2,550 nautical miles. So this will be equal to theta, which is what we are looking for, and then we multiply this by 60, and then we also multiply by cos beta, and we know that beta is the degrees in which this latitude here lies from the equator, which is 50 degrees. So we're going to have here cos 50. And then the next step, we divide both sides by 60 multiplied by cos 50. 60 multiplied by cos 50, so that we get the value of theta by cancellation on the right side of the equal sign. So we end up getting theta to be equal to 66.12 degrees. So there's airport B, we are looking for the longitude of airport C, and then the Greenwich meridian is passing here. So we know that this is 36 degrees, but then the value of theta is 66.12, and therefore the longitude of airport C will be equal to 66.12. We are looking for this arrow here to subtract 36 degrees, which will be equal to 30.12 degrees. Therefore, the position of airport C will be 50 degrees north and 30.12 degrees east. And that is the solution for part B, Roman 1. Part B, Roman 2. The local time the plane lands at sea if the average speed for the whole journey is 1,200 kilometers per hour. So first, we need to find the distance in kilometers from airport B to airport C. So we are going to consider this relationship that 1 nautical mile will be equal to 1.854 kilometers. So what about 2,550 nautical miles will be equal to how many kilometers? So by cross multiplication here, we are going to have 2,550 to multiply 1.854 kilometers, and then we divide by 1. So we end up having our answer as 4,727.7 kilometers. So we can easily tell the distance for the whole journey to be equal to, we know that the distance from airport A to airport B, we had found 10,010 in part A, and then we are going to add the distance from now airport B to airport C, which is 4,727.7 kilometers. And this will lead us to getting 14,737 kilometers. Now, we need to find the total time taken as far as average speed is concerned. So we're going to say here that average speed will be equal to the total distance traveled divided by the total time taken. The total distance traveled is 14,737.7 kilometers, and the average speed we've been given to be equal to 1,200 kilometers per hour, and therefore we are looking for the total time taken. So by removing the denominator here and making the total time taken the subject, we are going to have the total time taken to be equal to the distance, which is 14,737.7 kilometers, divided by the speed, which is 1,200 kilometers per hour. And the solution here will give us 12.28 hours, of which, when you convert into hours and minutes, you are going to get 12 hours and 17 minutes. And remember, this time is inclusive of the 45-minute stoppage at B. And then we need to find the difference in time between the longitude of airport A and B and the longitude of airport C, now that we know the positioning. And the value of theta between B and C, we found it to be 66.12 degrees. If 1 degree will be equal to 4 minutes, what about theta? 66.12 degrees will be equal to how many minutes? By cross multiplication, we are going to have 66.12 to multiply by 4 and then divided by 1. So the solution here will be equal to 264.48 minutes, which when converted into hours and minutes will lead us to getting 4 hours and 24 minutes. So this is the time we need to add to the duration of travel so that we get the local time at airport C when the plane arrived. And so by addition, we are going to have 12 hours 17 minutes to add 4 hours and 24 minutes. And this will lead us to getting 16 hours and 41 minutes. So the journey started at airport A at 1400 hours, and this is on a Monday. So when we add 16 hours and 41 minutes to this time here, we are going to arrive at 0641 hours on the following day, which is on a Tuesday, and this is our solution. Question 2a. A plane flew due east to a town Q from a town P 60 degrees north, 16 degrees west. The plane covered a distance of 5,400 nautical miles. Find, Roman 1, the position of Q, 4 marks. Roman 2, the time at P when the time at Q is 0140 hours on a Wednesday, 3 marks. Part B. Another plane flew from P to Q through the North Pole at a speed of 667 1/3 kilometers. Determine the time taken by the plane. Take pi to be equal to 22/7 and the radius to be equal to 6370 kilometers. 3 marks. So we start by locating town P. We've been told that town P is on a latitude 60 degrees north and on a longitude 16 degrees west. So this is where we find the point P. And then you're told that the plane flew due east to a town Q. So the town Q is on the eastern side of the town P. So I can capture with an arrow in that direction. And then we are also told that the plane covered a distance of 5,400 nautical miles. So the distance from P to Q will be 5,400 nautical miles, and that will be along a circle of latitude or along a small circle. So in part A, Roman 1, we are being required to find the position of Q. So in order for us to find the position of Q, we are going to consider the fact that we've been given distance in nautical miles, and remember we are moving along a circle of latitude. So we are going to use the formula distance in nautical miles, and this will be along a small circle. It will be equal to theta multiplied by 60 cos beta. And the distance we've been given as 5,400 nautical miles. Theta is what we are looking for, and then to multiply 60 cos, and the value of beta is the angle that latitude is from the equator, which is 60 degrees. So you're going to have cos 60 degrees. So therefore we solve for theta, and before you do that, if you multiply 60 times cos theta, you're going to have 30. So this will multiply by theta here to be equal to 5,400 nautical miles. And therefore, when you divide both sides by 30, you're going to get the value of theta to be equal to 180 degrees. And if this is the value of theta, we can say that the points P and Q are on longitudes that are directly opposite or antipodal. So as far as locating the point Q or the town Q is concerned, I've considered a small sketch here. So P is on the western side of Greenwich, and you can see that 6 degrees are taken care of in this direction. And then we know that the value of theta, which is from P to Q, is 180 degrees. And therefore, since Q is on the eastern side of Greenwich, the angle here, or the degrees on the eastern side, will be equal to 180 degrees to subtract 36 degrees. And therefore, we are going to get our answer as 164 degrees east. And therefore, the position of Q will be 60 degrees north and 164 degrees east. In Roman 2, we are being asked to find the time at P when the time at Q is 0140 hours on a Wednesday. So let's find the difference in time between the longitude of town P and the longitude of town Q. And we start by considering that if 1 degree will be equal to 4 minutes, what about 180 degrees will be equal to how many minutes? And then by cross multiplication, you're going to have 180 degrees to multiply by 4 and then divided by 1. And the solution here will be equal to 720 minutes, which when you change into hours by dividing by 60, you're going to get 12 hours. We've been told that the time at town Q is 0140 hours, and you're looking for the time at P. And remember, we said that the more you go to the west, the behind the time. So the time at Q was 0140 hours, and this was on a Wednesday. And therefore, if we subtract the 12 hours, we are going to arrive at 1340 hours, and this will be on a Tuesday, the previous day. So this is our solution. Part B of the question. We are being told that another plane flew from P to Q through the North Pole. So this is movement along a great circle through the North Pole at a speed of 667 1/3 kilometers per hour. Determine the time taken by the plane. Since the speed is given in kilometers per hour, it means we are going to consider the distance in kilometers, and this is along a great circle. And we know the formula to be equal to theta divided by 360 degrees, and then we multiply by 2 pi r. And what is the value of theta? It will be equal to 30 degrees, that means moving from 60 degrees north to 90, and then from 90 back to 60. So you've got 30 degrees plus 30 degrees here. So theta will be equal to 60 degrees. Therefore, the distance will be equal to theta, which is equal to 60 degrees divided by 360 degrees, and then we multiply by 2 times 22/7, and then we multiply by 6370, the radius of the earth. So when you solve that, you're going to arrive at 6,673 1/3 kilometers. Now that we have the distance and also the speed which has been given in the question, we can now find time using the relationship that time will be equal to distance over speed, and we know that the distance will be 6,673 and a third kilometers, and we divide this by the speed, which is 667 and a third kilometers per hour, and the solution here will be equal to 10 hours.